Greetings, chemistry students. Today, I'm going to introduce a concept in stoichiometry called limiting reactant problems, where we're going to ultimately look at which factors limit how far a chemical reaction can proceed. For instance, if you're trying to burn a candle, you would say, well, it's going to burn until the entire candle has burned up. But if you were to put the candle inside of a jar with the lid on it, that candle's going to only burn until you use up the oxygen. Because in that scenario, oxygen is your limiting reactant. It's what runs out and stops the reaction. Whereas in open air, the wax is the limiting reactant because there's plenty of oxygen on planet Earth for that candle to completely burn up. So to give you another example before we get into our sample problem, let's go back to an analogy I used the other day about if you're working at Chick-fil-A. Let's say it's your first day on the job today. You go in there and they give you the job of taking inventory. Because we have the recipe that to make a Chick-fil-A sandwich, you need a piece of chicken, a bun, and 2 pickles. And that makes a sandwich. So you are going into the kitchen and you're taking inventory, and you count that there are 150 pieces of chicken. There are 180 buns. And yes, you're really this bored on your first day on the job. There are 200 pickles. So how many sandwiches could you make? Well, if you think about this for more than 2 seconds, the answer is you can make 100 sandwiches. You've got enough chicken for 150 sandwiches, enough buns for 180, but since it's 2 pickles to 1 sandwich, you only have enough pickles for 100 sandwiches. Once you made 100 sandwiches, you are out of pickles. Pickles are the limiting reactant, and so you stop at 100 sandwiches. Because Chick-fil-A would never dare to serve their chicken sandwiches without those 2 pickles on it. They're essential. So let's take a look at a chemical reaction and a sample problem. So we've got this reaction here. 2 butane molecules react with 13 oxygens to make 8 carbon dioxides and 10 waters. That's a combustion reaction. We've seen this before. It's balanced already, which is nice. So the problem says, if 35 grams of butane react with 5.1 times 10 to the 23rd molecules of oxygen, how many grams of carbon dioxide are produced? So the key indicator that you're doing a limiting reactant problem is that you're starting with 2 different things. We're starting with 35 grams of butane, and we're starting with 5.1 times 10 to the 23rd molecules of oxygen. And then we're trying to find grams of carbon dioxide. So we're going to work through this problem twice. And then, just like with the Chick-fil-A example, whichever one makes the least amount of carbon dioxide, well, that's the ingredient that ran out first. That's our limiting reactant. So our answer is simply the smallest of the 2 answers. So to solve this first problem, we're starting with grams of C4H10. So the first step, since that's not moles, is we need to convert our grams of C4H10 into moles of C4H10, where 1 mole of C4H10 is going to equal the mass of carbon times 4 plus the mass of hydrogen times 10. And so that is 58.12 grams. Then we can do the stoichiometry step where we switch from moles of C4H10 to moles of the thing we're trying to find, carbon dioxide, where since up here we have a 2 in front of C4H10 and an 8 in front of CO2, that's the numbers we use. And then we continue on, and we get it into grams because it wants an answer in grams of CO2. So we go from moles of CO2 to grams of CO2, where 1 mole equals the mass of carbon plus 2 oxygens, which is 44.01. So we work this problem out, and I'm coming up with an answer of 106 grams of carbon dioxide. Now, let's try this problem a second time with our molecules of oxygen. So we're going to go from molecules of O2 into moles of O2, because that's the first step, is get into moles, where 1 mole is 6.022 times 10 to the 23rd molecules. Then we'll do our stoichiometry step, where we go from moles of O2 to moles of CO2. And we use our 13 for the oxygen and our 8 for the CO2. That's where we're using these. Let me try the. That's where we're using these numbers in our conversions. And then our last step is to go to grams. So it's going to be the same as in the previous example. Mole is 44.01 grams of CO2. And so when we work this one out, 5.1 times 10 to the 23rd divided by 6.022 times 10 to the 23rd times 8 over 13 times 44.01 over 1. I'm coming up with 22.9 grams of carbon dioxide. 22.9 grams is smaller than 106 grams, so that is our answer.